Alright, so when you hear the word median, what do you think about? Mean, median, and mode. What does the median mean?
Middle.
The middle. If you've got a lot of data, it's the middle number. Okay? So when we write the definition of a median, I'm going to put of a triangle. Okay? So it doesn't get confused with the median in a list of data. But it's similar because it's going to be the middle. Okay? The median is the segment drawn from a vertex to the opposite side midpoint. I probably should have phrased that a little different. If you haven't written it down, I'm going to rephrase it. To the midpoint of the opposite side. To the midpoint of the opposite side. So maybe knowing the midpoint formula will be helpful. Just a real quick thought of what's the midpoint formula? Side note. It's an actual coordinate, x plus x over 2. So really, you're averaging your x's and you're averaging your y's. Okay? The midpoint formula is going to be helpful. Okay? So let's draw a triangle and see what that looks like. We'll draw a decent sized triangle. Okay, so we take a vertex. You pick one. Okay? And then you're going to go to the opposite side's midpoint. So right now I'm just going to guesstimate what the midpoint is. But I'm going to put marks down there because midpoint means cut it into two congruent segments. So half is on this side and half is on that side. So I'm cutting it in half. That's a median. How many medians could I draw in a triangle? From a vertex, how many vertices do we have? 3. Could I draw one from this vertex to the midpoint of that opposite side? So this vertex has an opposite side, so I'm going to kind of pick where's that midpoint, and then I'm going to connect them. So this side's going to equal that side. That's a median. Can I draw one more? Yes. This vertex to, we're going to pretend about right there for that one. I need to draw my line a little better. So that this side equals that side. If you ever see a triangle with all those little tick marks on the outside that we've hit, this piece is congruent, we've just drawn medians. We can draw 3 medians in a triangle. Does anybody notice anything about all 3 of those lines? They hit at one specific point. Okay? That point is called the centroid. And there's a centroid theorem, which you can write down later. But the centroid is actually the point of concurrency. Concurrency just means where they all meet. Point of concurrency of the medians. And we kind of talked a little bit yesterday about the centroid theorem, and it's always going to be 2/3. Okay? 2/3 the distance. The centroid is always closer to that midpoint. Maybe I'll say that somewhere. The centroid is closer to the midpoint and farther from the vertex. That's just kind of a side note. Because we need to know, because we're going to start breaking it down. From the centroid to that side length where you had a midpoint, okay, is going to be a third of your line. The centroid theorem says the centroid is 2/3 the way from the vertex. So every median, I'm going to divide into thirds. It's still going to be 2/3 of the way, even if it's special. Okay? Somehow it always works. I don't know. So, when I divide this into thirds, the 1/3 is going to be from the centroid down, and the top from the vertex to the centroid is going to be divided into 2/3, two of them. Okay, they're equally spaced. We're happy. I'm not going to draw any more numbers in that just yet. We'll come back to it. I am going to draw some other types of triangles. Kitten has brought up some different triangles. We're going to see, is it going to be any different? What if I have a right triangle? What if I have a right triangle? Vertex to the midpoint of the opposite side. Vertex to the midpoint of the opposite side. Can I ask you a logic question? I've just drawn two medians. I can still draw one more. But where these two lines have intersected, does the third line have to intersect at the exact same spot? Yes. So do I have to draw that third median? No, I don't. To know that the centroid is going to be right there. Okay?
So once
Once
you find two,
you find two, you don't have to draw that third one.
what happens if you don't draw it in the right spot? But it's a general area.
We're going to talk about general areas because sometimes they're going to ask you for what are the coordinates of the centroid. So we're going to put one on a graph in just a minute.
Oh, but like that's on graph. I mean like just freehanding. It's like you can't get it perfect.
Yeah. They're generally not going to ask you to freehand. I'm freehanding just to kind of give you an idea, but we're fixing to put one on a coordinate plane and we're going to find the exact spots. Okay? So yeah, that's a general generic spot where it is. Okay? If you've drawn two, then that's good enough. Okay? Because my third one, when it doesn't go through, I just make the dot bigger. Okay? That's what I do. Is the centroid still 2/3 of the way? Is it still inside the triangle? What if I draw an obtuse triangle? Whoa, that's really obtuse. Didn't quite mean to make it that obtuse. Can I still draw vertex to the midpoint of the opposite side? It makes it a little harder. We're going to pretend that that's the midpoint, so we're going from here. Oh my goodness. Thank you. I don't quite believe it, but. And then I'm going to go from this vertex. This is the long line is the hardest one to figure out what's the midpoint. We're just going to do that. Pretend. Okay? It's the shortest line to draw, but to try to find the midpoint, it's hard to find. Is the centroid still inside the triangle? Yes. So I'm going to put another little bullet point up here that says the centroid will always be inside the triangle. Now, the centroid, why do we ever need to know where that point is? Well, not necessarily, no. We're not going to find area, it's not a base and a height. It actually is the point. Okay, pretend. I know nobody has triangular dishes, okay? That would be weird. But if you find the centroid, that's where you can put your finger and make it balance. It's a balancing point. It's kind of weird. That if I put my finger right at that point right there, and I can hold it, it will actually balance. No. No, I don't.
So you're
Please.
telling me that the area of the top 2/3 is the same as the area of the bottom third?
Pretty much. I mean, we're not talking about areas, but yeah, this is far away. It's still 2/3 the distance away from all of them. So that's going to be your center point of same amount to balance it. I don't exactly know how it works. I just know that that's the one neat thing about it.
Because it wouldn't balance if it wasn't the same weight.
Yeah.
Right? So,
Now, this doesn't say your dish that you can have other stuff on top of your dish. Okay? This is the point of where it can balance. Yeah. Oh no. Alright, so what happens if I give you a coordinate plane and I give you coordinates? So go ahead and we're going to draw an ABC. Is it too light, too dark?
Medium doesn't work.
it works, you just can't see it.
That's
Exactly. So it
Wow.
doesn't work.
It's red. Alright, if I give you A is at negative 3, 5. A is at negative 3, 5. B is at negative 2, 1. And C is at negative 7, negative 7, 3. And I ask you to find the coordinates of the centroid. What do you think the first thing you need to do is? Graph this triangle. So negative 3, 5. 1, 2, 3, 4, 5. There is A. B is negative 2, 1. C is negative 7. Negative 7, 3. Not necessarily. Looks can be deceiving, especially when there's slanted lines. Okay? Because I can see A to B, we went up 4 and over 1, but this one we went back 4 and down 2. Not going to be the same. So if I ask you to find the centroid, what are you going to do?
Guess.
No. We're going to do what?
Find the vertices and then divide each side by half.
Midpoints.
Oh.
Midpoints from a vertex to a midpoint. So do we need to know that formula I gave you a second ago?
Yes.
Yes. So what point, Carter, do you want? Carter Parker, give me which side do you want to find the midpoint of? A to C. So here we go. From A to C, I'm using these two coordinates. Okay, I'm doing this pretty quick. What's negative 3 plus negative 7? Negative 10 divided by 2 is? Negative 5. 5 plus 3. 8 divided by 2 is? 4. So the midpoint of AC is negative 5, 4. So where's negative 5? Here. Go up 1, 2, 3, 4. Should it be on the line? Ish. So that's negative 5, 4, which is the midpoint. Now, where do I need to draw that midpoint to? Point B. Vertex B. That's one median. What's another median we might want to do? Carter Manwaring, you want to give me another one?
Sure, I think AB would be the easiest.
AB is probably going to be the easiest one. So let's go AB, these two right here. Negative 3 plus negative 2 divided by 2. What?
No, negative 2.
Negative 2 and a half. Ultimately, you can say, what's halfway between negative 2 and negative 3? Negative 2 and a half. Okay? 5 plus 1. 6 divided by 2 is 3. So over here at negative 2.5, up to 1, 2, 3. Is that the point, the midpoint? Okay. What are we connecting it to? Point C. Look how nice that is to go straight across on that line. Now, your guesstimate needs to come from finding the midpoints. Sometimes they will end at fractions. I didn't give you that one. Right there is my centroid. So the centroid is where? What is the point of, what are the coordinates of the centroid? Negative, I think this should be negative 4, 1, 2, 3. Okay? So you can find the centroid by plotting the midpoints and then connecting those lines. We only had to do 2 of them. Okay? You feel okay? If I have a centroid, if I have a triangle, let's see. Can I draw a triangle that will still show the inside piece? Maybe. Ooh, we're just going to do that. So if I draw the centroid, see how nice that works sometimes? Very exactly 3 on this side and 3 on that side. It's because it's isosceles, yes. But the next one is not going to be as nice and pretty. It goes up 2 over 1, up 2 over 1, so it's actually right here. It's supposed to be right on the line. It should go through here, through there, all the way to there. Okay? So where's my centroid? Right there. Okay? Now, I know we can count boxes. Okay? So I'm going to give you the first one as the boxes. I need some letters. Let's figure out some letters. I don't want to do ABC. W, X, Y. This is P. This is D, and that is R. Okay? Can someone name a median? X to what? X to R. What's the other one? D to Y. We have 2 medians. What is the centroid? P. Point P. With our centroid theorem, the 2/3. What is the distance? Okay, we're going to pretend we can't count boxes. Okay, you can't count boxes. Or the boxes represent different things. Okay, you're in kindergarten. You cannot count boxes. And I tell you, X to R is really 12.9. Okay? If I tell you the entire length, okay, what did I say we're going to do with every median? Well, okay, yes, after you find it, but when we have the centroid with that line, we're going to cut it into thirds. So we're going to take this and this, we're going to divide it into thirds. Really, that last one should be right here, but because I can still count. So we're going to take, if you're given the whole thing, you're going to divide that whole thing by 3. So if I ask you, what is X to P? What is P to R? Can you answer those things? What did you get when you divided 12.9 by 3? So you have 4.3. Is that the same in every section? Yes. So then can you go back and find, well, what is X to P? 8.6. What is P to R? 4.3. They'll give you some decimals. Okay? What about Y to D? What if I tell you, actually I'm going to tell you P to Y. I'm going to tell you Y to P equals 10. Y to P equals 10, and then I'm going to ask you what is P to D equal, and what is Y to D equal. Okay? You first have to know, what did I give you? Okay, did I give you the whole thing? Did I give you the little piece? It's not half. Y to P is right here. What have we done with our median? Did we cut it into thirds? So that piece right there, I need to do what with? Divide it in half. So every section is how much? 5. So what is P to D? 5. What is Y to D? 15. Okay, divide them into thirds, and then put what you know what you're given where you know it should be. Okay. All right. Last but not least, altitudes. We said that we spent all this time on medians and centroids. Poor altitudes aren't going to get much attention. What do you know about altitudes? It's like an airplane. It's how high you are, your altitude. Okay? In a triangle, have you seen the altitude of a triangle? It's the height of the triangle. So the altitude of a triangle is the segment drawn. From a vertex perpendicularly, I probably should put perpendicular earlier. Perpendicular to the opposite side. So this time, we don't care about the midpoint. We care about perpendicular. Okay? And when you have a nice isosceles triangle, when I draw from a vertex perpendicularly, we just care that it hits at a right angle. Okay? The top going down is nice. I know that's not a perfectly straight line. We're going to get over that. From another vertex, it's a little harder when I'm going sideways, because I'm going to have to estimate that that's going at a right angle. Okay? If I draw the last one at a right angle, okay? It's going to be right there in my triangle. Do they still all hit at the same spot? Yes, they will. So we call that point of concurrency an orthocenter. It's the point of concurrency. I feel like I spelled that right. Concurrency for or of the altitude. I don't care what you do, but focus on what you're supposed to be doing. Okay? The point of concurrency is called the orthocenter. So that acute triangle, it landed right there. Earlier, we drew some other type of triangles. What happens if we draw a right triangle? Where? Vertex, straight down at a right angle. It's already there. Wait, what about this vertex? To a right angle. Whoa. If there's a right triangle, the orthocenter will be on the triangle. Okay, it will be at the right angle. What about an obtuse triangle? And then we'll go back and try not to draw too big of a triangle. Okay, so when I go a segment from the vertex to the opposite side perpendicularly. Question: from this vertex, can I draw a right angle that lands on that side length? Nowhere can I. So what do you see in triangles when you're finding the area of obtuse angles? What do? Draw dotted lines, don't they? They extend that side to be able to draw a line at a right angle. Okay? Well, we have another one. I have a vertex right here, and that's going to definitely land inside. Did those two lines meet? Where? Outside, so I need to keep them going. They haven't met exactly where I've drawn them. What about our third side? Could I draw from this vertex? Do I need to extend that one? And draw at a right angle here, but I'm going to need to keep these going. Oh, that one got really bad. I'm going to pretend. They draw them very nice in your book. On page 206, they do dotted lines outside where those altitudes keep going outside and they meet outside your triangle. Okay? What you need to know about your orthocenter? Acute triangles, the orthocenter will always be inside. I don't want to use the word always. The orthocenter will be inside. Inside the triangle. A right triangle, the orthocenter, will be on the triangle at the right angle. And last, the obtuse triangle. The orthocenter will be outside. The triangle. Okay? From this paper, you have about 8 problems with that to work on. Okay? Lesson 32. Do I need to go back to it? You got that written down? That's the biggest piece right here, which they tell you in your book. Lesson 32, practice. Number 3 and 9 through 12. Lesson 32, practice. Can I go now? Did that change? Lesson 32, practice. And 3 and 9 through 12. Just those numbers. Have a great rest of your day.